Okay, so what we are going to do today and tomorrow is we are going to approximate the area under a curve. Okay, now if a curve is a line, okay, we can obviously use a geometric figure and figure out the exact area from the curve to the x-axis. Okay, that's what we're worried about. All right. However, if we have something like a parabola, there's not really a nice geometric figure to get that exact area. So what we're going to do today is we are going to draw rectangles under the curve to approximate the area from the curve to the x-axis. Okay? Today we're going to use rectangles. Tomorrow I'm going to teach you how to use trapezoids, and those will be the two methods for approximating the area under the curve. So what your quiz will entail are the sums from Friday, and then the rectangles from today and trapezoids from tomorrow. Okay? So it's going to be a very geometric quiz. Okay? So this is what we're going to do, and I'm going to show you an animation here in a little bit. But we're going to take a curve, and we are either going to draw rectangles that we call right rectangles, which means the right side of the rectangle sits on the curve. Okay, so we draw the rectangle where the right side of the rectangle gives us the height of the curve. The height of the curve gives us the height of the rectangle on the right side. Or, so this is right, these are left, where the left side of the rectangle, we get the height of the curve. Or we can take the middle of the rectangle and use the curve to give us the height of our rectangle. Okay, so we're going to do it 3 different ways today. Okay? Now, I'm going to click this button here. We're going to go to a website. Okay, so here's a parabola. These are left endpoint rectangles. These are right endpoint rectangles. And these are midpoint rectangles. Now, what do you think the case is going to be if we increase the number of rectangles that we use? What? It's going to be more accurate. If we find the area of those rectangles, it's going to be more accurate to the actual area under the curve than if we use that number of rectangles, okay? So obviously, the more rectangles we use, the better. However, if we're finding the area of 40 rectangles, that is very tedious, right? So we're going to stick to a number that's manageable, okay, to find the area. But we know the more rectangles we use, the more accurate that we are going to be. Okay. So, let's go back here. Okay, so this is going to be how we're going to approximate. I'm going to have you write these down, and then I'm going to hand out the problem. Okay. So this is how we approximate. First of all, we need to decide how many subdivisions to use. How many rectangles are we going to use? Typically, this is going to be given to you. Okay. And we call this number n. N is the number of rectangles we are going to use. We then need to know if we're using right, left, or midpoint. Once again, this will either be given to you directly, or it is something that you will have to infer. And I'll show you what I mean once we've done all these examples. So these 2 bullet points, they're going to be given to you in some way, okay? From the next ones is really what we have to calculate, okay? We need to figure out how wide our rectangles are. How do we find the area of a rectangle?
Length times width.
Okay, length times width. So first of all, we need the width of our rectangles. Now, if I say that we're finding the area from A to B, and we know we need n rectangles, how do we know how wide each rectangle needs to be? How do we figure that out? Okay, we got to take our length and divide it by the number of rectangles. So you're going to take where you end minus where you start and divide it by the number of rectangles. And we're going to call that our change in x. That's how wide our rectangles are going to be. Then we have to calculate the heights of our rectangles, okay? Now, this is going to be different if we're a right endpoint, a left endpoint, or a midpoint, but our function value is going to give us the height of the rectangle. Once you know the widths of all your rectangles and the heights of all your rectangles, then you can find the area of your rectangles and add them all together. Okay? Now, the widths of the rectangles are always going to be the same. The heights of the rectangles will change. So we can use that to kind of help us calculate faster. But it's really just a matter of finding the area of rectangles and adding them together. Okay? Now, I'm going to give you this foldable, and Joe is going to hand you a pair of scissors because Joe is so kind. This is just going to be a way for you to have all of the area approximations together in one document with examples that have pictures. Okay? Does everyone have a piece of paper? Okay, what I need you to do is have it on this side right here. Okay? And you are going to fold it along this line so that you can still read area approximations, and then your 4 graphs are in the front. Okay? So fold it along that line. Okay? And then I gave you scissors. You're going to make it so you have like 4 little bitty books. Okay? You're going to cut along, now that you have it folded, okay? Now that you have it folded, you're only going to cut on these where the words are, and you're going to stop at the fold. So you're going to make 3 cuts. 1, 2, 3, stop at the fold. So see, here's mine, how I can, open 4 different things. back there? Yes, okay. So, we are going to start with your top one, okay? We're going to find the area under x squared over the interval 0 to 2. Now, open up the flap, and it says, in a left-hand sum, the height of the rectangle is given by the function value on the left side of the interval, okay? So, with it open, we need to figure out what our change in x is. Okay. So, I'll remind you, I am going to go ahead and say that for all of these examples, we are going to use 4 rectangles. Okay, so go ahead and make a note to yourself on there that n is 4. Okay, so let's go ahead and find the change in x. Since our interval is 0 to 2, we're going to take 2 minus 0, and then we'll divide it by the number of rectangles we have, which is 4. So our change in x is 1/2. Okay. Now, we need 4 rectangles where the left side of the rectangle hits the function. So, go ahead to the very front, your picture, you'll notice that these grid marks are by 1/2. Did that on purpose. Okay? So, this rectangle, right, from 0 to 1/2, okay, this is the left side of that interval, so its height is, it doesn't have a height, okay? From 1/2 to 1, here is the left side of that interval, so there is that rectangle. From 1 to 1.5, the left side would be here. There's that rectangle. And then from 1.5 to 2, this would be the left side, so there's that rectangle. So our job is to find the area of those 4 rectangles and add them together. Now, not always will you need to draw a picture, but I think as we take notes, it's going to help you understand what we're actually finding. Okay, so go ahead and flip it open. We're going to find the area, and you can use this blank space right here. Okay, what's the width of each of these rectangles? 1/2. Okay, that's that change in x. That's the width of all of our rectangles. So this first rectangle goes from 0 to 1/2. Since we're talking about a left endpoint, the height is going to be the function value at 0. This second rectangle has width of 1/2, and then its height, since it's the rectangle going from 1/2 to 1, but we're using the left side, its height is a function value at 1/2. This third rectangle from 1 to 1.5, it has width of 1/2, and then its height, since we're talking about the left side, we're going to use the function value at 1. And then this fourth rectangle from 1.5 to 2, since we're using that left endpoint, it has a width of 1/2, and its height is the function value at 3/2. Okay, so all we have to do is plug those values into our function to figure out the height. Okay, so f of 0, if we plug 0 into our function, what do we get? Say 11. 0. We plug 1/2 into our function. What do we get? 1/4. This rectangle right here has a height of 1/4. Our function value at 1. Y equals x squared. There should not be only one person answering this question for me. What's our function value at 1?
1.
Thank you. The height of this rectangle is 1. Okay. And then the function value at 3/2.
9/4.
Thank you. Okay, now, to save you some time and pencil lead, since we know that each of the rectangles has the same width, you could write 1/2 times 0 plus 1/4 plus 1 plus 9/4, and that would be fine. Okay. We could have done that from the beginning, right? And this is going to be the same every time. It's 9/4 plus 1/4, 10/4 plus 1. Okay, so we have 1/2 times 14/4, which gives us 57/4. Our area approximately is 7/4. Look at that picture. Is that an under or over approximation? Why is it an under approximation?
Since there's still a lot of areas still under the curve.
Okay, our rectangles are sitting under the curve. There's a lot of blank space. So that is an under approximation. Okay, we know that the area is a little bit more, but it's still close to what the actual area is. All right, let's go to the third flat fold. I don't know what you want to call it. We're going to do right hand endpoints. Now, the right hand endpoint means that our rectangle, we get the height from the right side of our function, of the interval. Okay? So we still have the same situation where our change in x is 2 minus 0 over 4. So we still have widths of 1/2. However, this time when we go to draw our rectangles, we're going to draw from the right side of the interval. So our rectangle from 0 to 1/2, we're going to get the height from 1/2 because that's on the right side. Okay? From 1/2 to 1, we're going to get the height from 1 because that's on the right side. Okay? From 1/2 to 3/2, we're going to get the height from 3/2. And then from 3/2 to 2, we're going to get the height from 2. So this is the area that we're going to find. Before we even get started, is this going to be an over or an under approximation? Over. Our rectangles are above our curve, so this is going to be an over approximation. Okay, so if you go to that big blank spot, when you open up your picture, we're going to go ahead and find the area. Okay, we're going to make a lot of steps, but eventually you're not going to have to write all of this down. You'll be able to maybe just make this into like a one equation question, okay? So, but we're going to break it down. So this first rectangle right here has a width of 1/2, and we're going to use the function value of 1/2 to get our height, because that's on the right side of the interval. from this rectangle right here has width of 1/2. The right side, we're getting the function value of 1 for its height. This third rectangle goes from 1 to 3/2, but on the right side is 3/2. So we're getting its height from the function value of 3/2. And then this last rectangle has width of 1/2. And then we're getting its function value from the right side of 2. So just give me a moment here. You see that for our left endpoint, we got function values of 0, 1/2, 1, and 3/2. Those are all the left side of those intervals. We didn't go all the way to 2, and that's okay. But we have 4 rectangles, and that's what we need. But here for our right side, we have 1/2, 1, 3/2, and 2. So we didn't start at 0, but that's okay because we had to get on the right side of those rectangles. Okay. So our function values, the function value of 1/2 is 1/4. So this rectangle has a height of 1/4. The second rectangle has a height of 1. That's x squared. Our third rectangle has a height of 9/4. And our fourth rectangle has a height of 4. Okay, those are just the function values there. Okay. Now, once you get comfortable with this, you're going to be able to just write this as 1/2 times 1/4 plus 1 plus 9/4 plus 4. Since they all have the same width, we can just factor it out, and you can do that from the beginning. Okay? So we have 9/4 plus 1/4 plus 4 plus 1. What does that give us? Huh?
What you mean it's all down is 15/4.
It's 15/4. So we have 1/2 times 15/4.
Oh, yeah, one is times 15.
Oh, we have 1/2 times 15/2. And so all together we have 15/4. Ooh, okay, I'm with you. Okay, and that's an over approximation because our rectangles are sitting above the curve. All right, now right and left hand endpoints are pretty straightforward. The thought process isn't too strenuous. Just organize your work. Okay, make sure I can tell where your numbers are coming from. You can't just give me an answer of 15/4. I need to see at least this right here so I know what your values are. Okay, you can show way more work if you would like to, but bare minimum, I need this step in the answer. Okay, you will get to use your calculator, so no panic. Okay, all right, so now let's make it interesting. We're going to go to the second flap, which is now the midpoint. Okay. We're still going to have to calculate our change in x. I kept it the same so that we could, you know, have it easy, I guess. Okay, so now what we are going to do is we're going to break this up into 4 rectangles with width of 1/2, but now we are going to take the middle height for our rectangle. Okay, so we're going to take the middle. So this time, a little bit of our rectangle is above the curve and a little bit is below the curve. You see that?
So wouldn't that be more accurate then, or not? Like, closest to the real area?
It might be a little bit more accurate, yeah. Now remember, our width is still 1/2, our change in x is still 1/2. Okay, but here's where we have to think a little bit harder. This first rectangle stretches from 0 to 1/2. What's the middle of 0 and 1/2? 1/4, okay? So that rectangle has width of 1/2 and it has height of f of 1/4. What is in the middle of 1/2 and 1? 3/4. So this second rectangle has width of 1/2 and height of f of 3/4. Okay. What is the middle of 1 to 1/2, or 1 to 3/2? 5/4. So that third rectangle has width 1/2, height f of 5/4. And then this fourth rectangle stretches from 3/2 to 2. What's the midpoint there? Isaac, you are on a roll. We have width 1/2, height of f of 7/4. Okay, now change in x is 1/2. So once you know one midpoint, you know all of the other midpoints are going to be 1/2 apart. So if you'd rather think of it like that, that is fine. You have 4 rectangles where they stretch 1/2 apart. Okay. So our area. Now I'm going to go ahead and skip a step. I'm going to go ahead and factor out that 1/2. Okay. We know that we can do that even from the beginning. Okay. What's our function value at 1/4? Thank you. Our function value at 3/4. Yeah. At 5/4.
25, 60.
Yeah. And at 7/4. 49/16. All right, so with your calculators or your minds,
That's more answers, okay?
no, not in this case. I would like a fraction answer in this
21/8.
case. This one was nice enough that, and I'm, Grant, I'll accept decimal answers. Okay, but the way that I wrote it up there, fractions. Okay, now, do not lose this foldable because that fourth foldable piece we're gonna complete tomorrow. Okay, but I do want to talk about a couple vocabulary terms, so you'll need to transfer back to your notes. Okay, I want to talk about the difference between inscribed and circumscribed. Okay, these two pictures right here, what's the difference?
One's left and one's right.
That's one difference. What's another difference?
One's an under and one's an over.
One's an under and one's an over. Okay, now this time the right approximation is the under and the left approximation is the over. Was that the case with our first example? No, it was backwards. Okay, so let's talk about when it is an under and when it is an over approximation. Okay, if we have rectangles that are inscribed, which means they fit under the curve, that's when we're going to have an under approximation. Here our curve is decreasing, So our right endpoints are going to give us the under approximation. Since our example, we had an increasing piece of our function, that is when the left will be inscribed and give us the under approximation. Okay, so it's going to depend on if your curve is increasing or decreasing where you're finding your area. Now, this second example, this is what we call circumscribed rectangles. They are on the outside of the curve. There are over approximation for the area. Since this curve is decreasing, the left endpoints were giving us an over approximation. The example that we did on your foldable, our function was increasing, which means the right side endpoints were giving us the over approximation. So there's a couple questions on your homework that will ask you for the upper and lower sums. Okay, give me the over approximation and give me the under approximation. You're going to need to know which one represents which. Okay, is it the right or the left? That's going to give me the over or the under. Okay, we've already kind of decided that midpoint may be a better approximation. It's kind of more of a pain in the butt to find though, right? The numbers aren't as pretty. Okay, but as far as left and right are concerned, we know for sure one is over and one is under. So let's take the case of y equals 6 minus x squared. We're going to go from 1 to 2 with 5 rectangles. Have a 15-second discussion of which one is going to be the lower sum. Right or left? Pod 4, what do you vote? The right-hand sums, do you agree, Pod 5? Okay, so we're going to do a right-hand approximation to find our lower sum. Okay. Trevor, how do we find our width?
The distance from 1 to 2 divided by 5.
Okay, difference between 1 and 2 and divided by 5. So our rectangles have width of 1/5. Okay, so I'm going to draw these. Don't feel like you need to. That's okay. Okay, that's what we're finding. Okay, so are we starting with a function value of 1? No, we're starting with this has a height where our function value is f of what? F of 6/5, okay? So our area, we know that each of these widths is 1/5. So I'm going to go ahead and factor out the width so I don't have to write it 5 times. Okay? That first rectangle has height of f of 6/5. The second rectangle has height f of 7/5. Our third rectangle has height f of 8/5. Our fourth rectangle has height f of 9/5. And our last rectangle has height f of 2. I got really excited with my handwriting. I'm sorry about that. Okay? So then what you're going to have to do, this is where it gets kind of boring. You're gonna have to take your calculator and find all of those function values, and then add them together, and then multiply by 1/5. Okay? I'll give you a moment to do that. If I were you, I would punch in 6 minus parentheses 6/5 squared plus 6 minus parentheses 7/5 squared plus 6 minus parentheses blah 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 blah. I'll just put that in all at once, figure out what that is, and then multiply by 1/5. You should be getting 3.36. Well, I kind of changed my mind. Decimals are going to be okay. Especially in this case where we're working with like 1/5. I'm gonna accept both kinds of answers, both decimals and fractions. 84/25. Okay. How about this, Cole? If the decimal goes on forever, you might want to change it back to a fraction. But see, this decimal actually stops. So 3.36 is the exact approximation. Okay. So I'm going to accept either, but fractions, if they're more accurate. Okay. Okay. And then if we're going to do an upper sum, okay, we're not going to find it. Let's just write down how we would find it. Okay, this would have to be the left-hand approximation. Then our area, we would still have the 1/5 for our width. Okay. Oh, I don't know. Draw these. Okay, but now this is the situation that we have. So if we're doing left endpoints and our first rectangle has height f of 1, our second rectangle, height of 6/5. Our third rectangle has height f of 7/5. Fourth rectangle, f of 8/5. And fifth rectangle, f of 9/5. Now, please pay close attention to the instructions I am giving you for your homework, okay? 33 and 35, don't say it, but I want you to use midpoints, okay? So you all have your gold sheet. Pay attention to I want you to find midpoint for that, okay? I will give you your quizzes back tomorrow, with it being Wednesday. We have 5 less minutes. So, do your homework. I'll see you tomorrow. Thank you for your participation. Larry and Cole, I need your scissors.
What?
Scissors?
Is there an NHS tomorrow?
Yes, NHS tomorrow. Will you write that on the board for me, please? NHS tomorrow.
I don't know yet.